So let's solve the NFL jersey problem. So remember the data that we had. We knew the cost per jersey was $10.90. The selling price was $24 a jersey. And our demand was, the expected value was 32,000 with a standard deviation of 11,000. And we assumed it was distributed normally over for that 8-week selling period. So the solution, remember when we did marginal analysis, we're going to try to figure out the cost of the shortage and the cost of the excess to come up with a critical ratio. So if I have a shortage, what is my cost? Well, that's one jersey I could have sold, so I lose my margin, which is just the selling price minus the cost. 24 minus 1090 comes out to $13.10. Then I want to look for what is the cost if I have excess, if I have an inventory of a jersey that I didn't sell. And what do I lose? The price that I paid for it, the $10.90. So I want to come up with my critical ratio, which is going to be equal to the CS, the cost of the shortage, which is P minus C. Divide that by the sum of the cost of the excess and the cost of the shortage, which is C plus P minus C, which simplifies just to P minus C over P. So this becomes my critical ratio, which if I just look at the numbers, do the math, comes out to 0.546. So this means that I want to cover 54.6% of the demand distribution. So I want to find a Q such that the probability that X is less than that, where X is the demand that is realized, is equal to 0.546. How do I do this? A couple ways. First, I can use a normal table or I can use a spreadsheet. So let's use the normal table, and you have this as an attachment to the unit. And so I have the standard unit normal table here that we've been using before, where the first column is the K value. And then I have the probability that X is less than K is the second column. The third column is a unit normal loss function, which we'll talk about in future talks. And this repeats for all different values of K. So if I want to find the probability of X being less than Q, where it's equal to 0.546. So what do? Well, I look down the second column to 0.546. I see that it's going to fall between these two values. So my K is going to be somewhere between 0.11 and 0.12. If I interpolate between that, it's roughly 2/3 in, we're almost halfway in between, and it turns out that it would come out to be that K equals 0.115, right in the middle between those. So now I know this. I recall that K, right, is equal, this is a normalization, where I take the Q that I'm trying to find minus the mean of the distribution divided by the standard deviation. And so what I want to find is the Q that gives this to me, so I just solve for Q, and it turns out that that comes out to be 33,267 units. So this is how you can find it using the normal table. Again, I just start with the probability that I need to cover, which is the critical ratio. I can also do this in Excel using this norm inverse function that we've talked about previously with 3 input terms: the critical ratio, the mean of the distribution, the standard deviation of the distribution, right? And that will return the exact same value. This is the profit maximizing quantity, so that I would order the Q star that would maximize my total profit for that 8-week period. But what if I can sell those leftover jerseys at a discount? Because it's kind of unrealistic that I would, if I have extra jerseys, I just throw them away. Maybe I can sell them, but at a lower rate. So what that's known as is salvage value. So let's consider 2 other costs here. The first is this salvage value. So suppose that if I sell a jersey, I don't sell it in the 8-week period, but if I sell it later, I can get a little value for it. Not as much as I normally would, but it's a discounted version amount. So there's some salvage value to it. Then I can also think of another cost, a B, which is a penalty for not satisfying the demand over and above the lost profit. Let's say I see there's a loss of customer goodwill and I can put a dollar value on that. That would be the B. So every item that I'm short, I get dinged another B, that I get charged for that. So if we think of those, then I can create and look at my cost of being short. So it's the loss of the margin, P minus C, but I also lose that B, that penalty for not satisfying demand. And my cost of excess is going to be the C, right? How much I paid for it but I subtract off this G, the salvage value, because I don't lose as much anymore because I can get some of that money back by selling it at a discount. So if I carry the math out, I come up with another equation for the critical ratio. But the important thing is to always think of this in terms of what is my cost of a shortage, what is my cost of excess, and then just do the ratio. So let's look at this in the case where I have a salvage value. So let's look at our problem again. And all this information is the same. Jerseys cost me $10.90. The selling price is $24 a jersey. My forecast demand is 32,000 with a standard deviation of 11,000. But now the only difference is if I don't sell my jerseys within that 8-week period, I can discount them and I can sell them for $7 a jersey. What does this do? Well, I can look at my cost of shortage and my cost of excess, as we just showed on the previous slide, and it comes out to $13.10 for the cost of shortage and $3.90 for the cost of excess. So my critical ratio comes 0.771. So what is this saying? This is saying that I should order a Q that covers 77.1% of the probability distribution. Notice that my Q is a lot bigger. I can cover more of the demand here. And so I want to select a Q where the probability of X is less than Q is equal to that 0.771. And again, I can solve that with a normal table or the spreadsheet. You might want to look at the table, see if you get the same number. But you end up with a Q star of 40.149 or 40,149 units. This is the profit maximizing quantity. So we're using the same principles. All we're doing now is adding in this other term, this discount, and we can find out what the critical ratio is. Notice that this is a lot bigger than our previous value, which was what, 33,849. By having this discount, this salvage value, that means I'm willing to buy a little more. I can buy a lot more because the risk of having too much went way down because of that discount. So we figured out how to find the optimal quantity. What we haven't figured out yet is how do I determine the profitability? And that's what we'll do in the next lesson. So let's wrap this lesson up and then do some problems and then come back and we'll learn how to determine the profitability of these situations.